Hello friends, this is Amit, your mentor at mentorbuddy.com. Here we have a short video based on time, speed and distance. And the question says, when David travels 9 by 10th of his usual speed, he would miss his local train by 5 minutes. But when he travels at 5/4 of his usual speed, then he would reach the station 9 minutes before the departure of the train. What is the usual time taken by the David to reach the railway station if he just manages to catch the train in that time? Four options have been given and we need to choose one correct option. Okay friends, so this is a pretty straightforward question which shows that once the speed is decreased, so he is missing the train, and when he is increasing his speed, he is catching the train. So it means what will be the time, usual time in which he is just managing to catch the train on time. Let's suppose he is able to catch the train normally in t time, that is the usual time is t, right? And if as we all know the basic formula of speed is equals to distance upon time. And if, see, he is traveling from where? He is traveling to catch the train from the same place. It means the distance in both the cases is same, and speed is inversely proportional to time when distance is constant. So what will happen when he is decreasing his speed? So the time will increase. If he is increasing his speed, then the time will decrease. That is, both speed and time is in reverse ratio. So for example, in normal case he is traveling with s speed and reaching in t time, correct? When he decreased his speed to 9 by 10th of the usual speed, then the time would have increased to 10 by 9 times. So the usual time would have been, if usual time is t, then the new time will be 10 by 9 times of t, correct? If speed has become 9 by 10th of the usual speed, then the time will become in reverse, that is inversely proportional, that is 10 by 9 times. So the time will be 10 by 9t. And if he is increasing his speed by 5 by 4 times, that usual speed is s and time is t, if he is increasing his speed by 5/4 of his usual speed, it means speed has become 5 by 4 times, then the time will be inversely proportional, it will become 4 by 5 times, right? So the new time will be 4 by 5t. okay, it has been given 4 by 5t, clear? So we have got two timings, that one time is 10t by 9 in which he is missing the train, and the second time is 4 by 5t in which he is reaching 9 minutes before. Okay, so it means the time taken earlier is 5 minutes more than the usual time, right? And time taken after increasing the speed is 9 minutes less than the usual time. And the time, see, by changing the speed, what is going on? See, when he is changing the speed, he is covering the delay of 5 minutes, and even he is coming 9 minutes before. So what is the time change between these two, the time difference between these two timings? See, in this time, that is 10 by 9t, he is getting late by 5 minutes, and when he is going in this 4 by 5t time, he is reaching 9 minutes before. The time difference between these two values will be what? That 5 minutes and 9 minutes before. That is, if we see on number line, that the person is reaching 5 minutes late, so he is taking this much time, right? From the usual time plus 5 minutes. If he is reaching early, so he is reaching 9 minutes before, that is minus 9. So the time difference between these two time will be 9 and 5, that is 14 minutes difference will be there, right? So that there will be 40-minute difference. So what we can write, that from here we can simply write that these two equation, the time difference is given as 14 minutes, clear? So we can take the denominator as LCM, so it will become what it will become? It will become 45. So in the numerator we get 50t minus, that is 9 into 4, 36t, right, is equal to 14. So we will get what? 14t is equals to 14 multiplied by 45 So that value of t will become how much? 14 will cancel out, it will become 45 minutes. It means the usual time taken by David is 45 minutes, as we have already in the initially we have taken t as the usual time taken. That is option D. So this is a question, this is a shortcut technique to find these type of question. That is, if the ratio of speed is going 5 by 4, then the time taken will be 4 by 5 times, right? So it will become 4 by 5 t. And if the speed of speed is becoming 9 by 10 times, then the time will become 10 by 9 times, so that it will become 10 by 9 t. And the time difference between these two timings is 14 minutes, because 5 minutes he'll that in first time he's getting 5 minutes late, in the second time he's getting 9 minutes early, so that the time difference in these two timings is 14 minutes. So you can quickly get the difference, that is 14, and you can get the value of t. There's very much asked question and very common question which you can solve with this trick. Thank you.